All right, to start off, we are going to take a quick minute to just kind of refresh sine, cosine, and tangent before we move into what we're really going to be working on here today. So we're going to be talking about how to go from one trig ratio to another, like how to convert between the different ratios when given certain pieces of information. So as a quick reminder, sine, cosine, and tangent, what you were probably taught back in the day when you first learned about this was the idea of SOHCAHTOA. And that was just like a mnemonic device to help you remember what went together. So sine is a ratio of opposite over hypotenuse. Cosine is a ratio of adjacent over hypotenuse. And tangent is a ratio of opposite over adjacent. Now, remember, these are all reflective of wherever you're starting from in the triangle. So you'll usually be told something like tangent of theta is 9 over 15. So first of all, you need to figure out where is theta in the triangle. Usually it'll be labeled, or it might tell you something about where to look based on where the numbers are. So we're going to say that this right here is theta. Remember, theta is just a symbol. It's like x. It means something. It's a variable. So a lot of times you'll use theta for angles and x for sides. Now, this is telling us a lot of information about this triangle. It doesn't seem like it, but it really is. Because what it's telling us is that the opposite side of our triangle is 9, and the adjacent is 15. So remember, to find our opposite and adjacent, the easiest trick that I can come up with is the hypotenuse is always easy to recognize because it's across from the right angle. So this has to be our hypotenuse. Now it's just a matter of determining which of the two sides that are left is the opposite and which is the adjacent. So what I always look for when I'm trying to figure it out is which side doesn't touch my angle. So my angle is here. The side that does not touch that is our opposite, which would mean since this side down here does not touch our angle, this has to be the opposite. And by process of elimination, this has to be the adjacent. So now I can label. So since the opposite side is 9, I'm going to say this is 9. The adjacent side is 15. So there we go. We've put all the information we know inside of the triangle, or that we were given, I should say. We know a lot more about this triangle. For example, we could find the hypotenuse. So using Pythagorean Theorem, we know that a squared plus b squared equals c squared, meaning the two short sides of a right triangle, the 9 and the 15 squared, added together will give us the length of the hypotenuse. So I could say 9 squared plus 15 squared equals c squared. So 81 plus 225 is c squared. So c squared is 306, meaning c is the square root of 306, which might be a nice number. Let's just check quick. It is not, so we'll leave it as is. So we would say the hypotenuse is the square root of 306. Now usually the way these problems will be written, it'll say something like, given that we know the tangent of theta is 9 over 15, and then they'll ask, like, what is the sine of theta? So what they're asking for you to do is do kind of what we just did here. Find that missing piece of information that we didn't already have, and then create the ratio that they're asking for. So they want to know sine theta. So from our angle, let's use sine, opposite over hypotenuse, and create a fraction. So from here, we would say our opposite side is still 9, but our hypotenuse is the square root of 306. So the answer to the problem would look like that. So let's go through that again. So I'll give you an example of a problem here. So it'll say something like, find the cosine of theta if the tangent of theta is the square root of 7 over 3. First things first, you're going to want to draw yourself a triangle. Now you'll notice that my triangles are almost never accurate. There's a reason for that. I don't want you to get used to the idea of being able to estimate your answers based on the picture. Reason being, I don't want that to become a crutch where you're just kind of guessing until you get a number that seems about right. Once you've got your triangle, you have to decide where theta is going to go. The only rule about that is that it cannot go in your right angle. It has to go somewhere else. So I, just for reasons, I guess, tend to pick the top corner as my theta every time. It doesn't have to be, it can be either one, it does not matter. But once we've decided on where theta falls, now we can go through and decide where does the square root of 7 need to go, and where does the 3 need to go. So since we're working with tangent, that means that we're talking about opposite over adjacent, and then I can put those on the correct sides of our triangle. So since square root of 7 has to be the opposite, looking at my triangle, that means the bottom side has to be the opposite, so this is going to be the square root of 7. And this side, this left side here, has to be 3. Now they want to know the cosine, which we know is the adjacent side over the hypotenuse. Now I have the adjacent side, but I don't have the hypotenuse, so I need to find that measurement. So I'm going to pull out my Pythagorean theorem here. A squared plus b squared equals c squared. And I'm going to plug in the two pieces of information I already have. So 3 squared plus the square root of 7 squared equals c squared, which would be 9 plus 7 is c squared. Now, a lot of kids get stuck on why that becomes 7. Remember, the square root and the squared, these two pieces, are inverses of each other. They end up canceling each other out. So whenever you see a square root of a squared, or a squared of a square root, either way around, they cancel each other out. So in this case, we get 9 plus 7 equals c squared, or 16 is c squared, which means that c, or our hypotenuse, needs to be 4. So now that I've found my missing piece of information that I needed, the hypotenuse, I can create my ratio. Cosine of theta is adjacent over hypotenuse, or 3 over 4. The other piece of what we need to talk about today is inverse trig ratios. So the 3 trig ratios you're familiar with are shown here on the screen. Sine, cosine, and tangent being opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, respectively. But there are actually 3 other trig ratios that exist. So the first one would be something we call cosecant. The second would be called secant. And the last would be called cotangent. Now, they still talk about the same type of triangle, they're still set up the same way, it's just a matter of being 3 new ratios that we haven't really talked about before. So instead of writing this, we would say cosecant, which we write out as CSC of your angle, and cosecant is a ratio of hypotenuse over opposite. Secant, which we would write as SEC, would be hypotenuse over adjacent. And cotangent would be COT, and it would be adjacent over opposite. Now you may have noticed that I have written these in a kind of a specific way. Cosecant and sine are like inverses of each other. These two fractions are just the upside down versions of each other. Same with cosine and secant. And with tangent and cotangent. So these are what we would call our inverse trig ratios. So they serve a purpose, which we'll talk a little bit more in detail about as we move forward in trigonometry, but it's just important to recognize, how do I get these ratios? So I would have these kind of next to each other. These are the only 6 you're ever going to really deal with. So I would have them next to each other in your notebook somewhere so you can kind of reference them. If I'm being 100% honest with you though, I don't memorize these 3 ratios. I just remember the names that go together, and then I remember that they're opposites. So like, I don't memorize that cosecant is hypotenuse over opposite. I remember that cosecant is the opposite of sine. So then I can just use sine and flip it over. Same with secant and cosine. I remember that secant is the opposite of cosine, and I just flip it over. And same thing with tangent and cotangent. So we're going to use these ratios in this type of problem where it might ask you to find the cosecant or the cotangent of an angle. So let's start with the one over here. So find sine of theta if cosine of theta is 3 square roots of 13 over 13. So I want you to take a moment, pause the video, make sure you figure out how to do this on your own, and come back. So assuming you've gone through, pause the video. I'm going to call this theta. If you called the other angle theta, that's okay. So this will be the 3 square root of 13. This would be 13. Using our algebra skills or our Pythagorean theorem, we can figure out the missing side length, which would be the square root of 52. So sine of theta would be the square root of 52 over 13. Give this other one a shot. I'm actually going to change this up for you a little bit because I don't like that number. So I'm going to say find the cotangent of theta if sine is 4 over 5. So take a moment, pause the video, give that a shot. Okay, so this time, just for reasons, just because I feel like it, I'm going to make this theta. It does not change anything at all about how I'm going to solve the problem. So opposite over hypotenuse, so this is 4, this is 5. Using Pythagorean theorem, I would work backwards to find this side length to be 3. Now that I've got my angles or my sides figured out, cotangent of theta is adjacent over opposite. So from our angle, that would mean adjacent, which is 3, or opposite, which is 4. So cotangent of theta would be 3 over 4. So I'm going to have you try this one. Take a moment, pause, see if you can do it on your own. Okay, we'll call this theta. So cosine is adjacent over hypotenuse, so adjacent over hypotenuse. Which would mean that this side length has to be 7, using Pythagorean theorem, in case you're getting stuck on that part of it. So I'm plugging in A and C because I have the one leg in the hypotenuse. And if I square this and subtract it to the other side, I get 49, which means that B has to be 7. Cotangent requires adjacent over opposite, so 24 over 7. So you'll see this used a lot on standardized tests. They will give you problems that look something similar, or they might even give you a just like a grid, I guess, a graph. Let's pull this up so we can show you here. So they might give you something that looks like this and say, given sine of theta is 7 over 22, find tangent of theta. And they're throwing this in here to kind of throw you off. It's actually just a reference to the unit circle. You would still do this the same way. So 7 over 22, we could draw that out pretty easily. 7, 22 from our reference, or from our angle here of theta. And we could find our missing side length and everything. So you might see pictures like this where they give you negative numbers, and we'll talk about how to deal with that in the future. So that's really just all we've been working on, is finding other trig ratios given a trig ratio.